Hello and welcome to the Features of Polynomial Rational Functions Part 1. This is Part 1 because tomorrow in class we're going to go much more in depth into wholes and other features. So this is just Part 1 of the Polynomial Rational Functions. This video is specifically on features. The next one will be on the graphing. So when we get into these features, a lot of the features are the same as our transformational rational functions. So like our vertical asymptote, y-intercept, domain ranges are all the same. There's only two differences. First difference is with our x-intercept. Pardon me. So with the x-intercept, you can still set the whole equation equal to 0 and solve. However, if you do that, you're always going to multiply by the denominator, and the denominator is always going to end up going away. So you can kind of have a shortcut and just set the numerator, or the top of your fraction, equal to 0 and solve. That's the only difference there. The really big difference is with the horizontal asymptote. Now, before, it was just you look to see how you're shifted up or down, and then that's the horizontal asymptote, boom, done. Now, we're looking at a few different things, specifically the degree of the numerator and the degree of the denominator. That's because when we're in polynomial rational form, you have an x on top and x on the bottom of your fraction. So there's really three different situations. Your first situation is the degree of your numerator is equal to the degree of your denominator. It's kind of your first situation. Your second situation is the degree of your numerator is greater than, that's the greater than symbol, the degree of your denominator. And the last situation is that the degree of the numerator is less than the degree of the denominator. Now, the first situation, where the degree of the numerator and the degree of the denominator are equal, this is what we'll be dealing with most often. However, you are going to have to be able to identify the other situations. So make sure you take a look at that. If the degree of your numerator is equal to the degree of your denominator, then your horizontal asymptote is y is equal to the ratio of your leading coefficients. Now, what does that mean? Well, if you have a function like 4x plus 1 over 2x minus 6, this is a polynomial rational function. It's a fraction. There's an x on top, x on bottom. Now, if we take a look at the degree here, numerator has a degree 1, and the denominator has a degree 1. So degree of the numerator and the degree of the denominator are the same. So we're going to look at the numbers out in front. We're going to look at that ratio. So we're going to have y is equal to 4 over 2, or 2. So in this case, we can say that the horizontal asymptote is y is equal to 2. So we're looking at that specific ratio there of the numbers out in front. You can think of it like that. So this is what we'll be dealing with most often. The second situation is that if you have the degree of your numerator is greater than the degree of your denominator, then you have no horizontal asymptote. When we say no horizontal asymptote, you still have a type of asymptote. You're going to have a slant asymptote, but we have cut that from the material for this unit. So you can just say no horizontal asymptote. For this example, if you had something like x squared minus 9 over x plus 3, degree of the numerator is 2, degree of the denominator is 1. So in this case, you go, oh, degree of the numerator is larger. No horizontal asymptote, and that's perfectly fine with me. Again, I'll have you identify these situations, but I wouldn't have you graph this. Lastly, we have the degree of the numerator is less than the degree of the denominator. Then our horizontal asymptote is just y is equal to 0. Every time, you don't need to solve, that's just what it's going to look like. So an example here might be if we have x minus 3 over x squared plus 4, degree of the numerator is 1. Oop, that's a weird looking one. There we go. Degree of the numerator is 1, degree of the denominator is 2, degree of the numerator is less than the degree of the denominator, so we can just say the horizontal asymptote is y is equal to 0. So this is something I would feel comfortable having you graph. So keep in mind we'll be dealing with this situation the most often, but be aware of these situations as well. So those are kind of all the new notes that we'll be doing, but we still want to practice going through and finding all of our features. So if you take a look at the blank notes, we're going to be looking at problems 5 and 7. Problems 5 and 7, only the features, not the graphing and the tables. So let's get started. So I'm going to move this up a bit. We'll go over those notes a little bit more in class. But problem number 5 is f of x is equal to negative 3x minus 9 over x plus 4. So for our vertical asymptote, we're still going to set our denominator equal to 0 and solve. That's still exactly the same. So we'll do x plus 4 is equal to 0. We get x is equal to negative 4. So our vertical asymptote is x is equal to negative 4. Boom, done. And then from here, if we wanted to do our domain, remember, domain is all of our values except for that vertical asymptote. So we'll be going from negative infinity to negative 4, and from negative 4 to infinity with a break because of our vertical asymptote. So that's kind of some of the stuff dealing with our x's. For our horizontal asymptote, in this case, I'm going to look at the degree of the numerator and the degree of the denominator. So I can see the degree of my numerator is 1, degree of my denominator is 1. It's the same thing. So if I take a look at the numbers out in front, I have a negative 3. Let me highlight that negative. We have a negative 3 over, there's nothing really out in front of that x, so you can think of that as a 1. So if we have negative 3 over 1, that's just negative 3. So we can say that our horizontal asymptote is y is equal to negative 3. And again, that's because the degree of the numerator was equal to the degree of the denominator. So we're looking at those degrees there. And that's our horizontal asymptote. And our range, we're to move over here, our range is going to be all of our y values except that horizontal asymptote. So our range is going to be from negative infinity to negative 3, and from negative 3 to infinity with that break because of the horizontal asymptote. Yes, I'm still recording. Sorry, I pressed something. So that's a lot of our features. Only 2 more features left to go, our x-intercept and our y-intercept. Now remember, for our x-intercept, you can set the whole equation equal to 0 and solve. However, if I was to do that, I might actually start doing it just for this problem. For the x-intercept, if I set my whole equation equal to 0, and I try and solve, I'm going to multiply by whatever's in the denominator. In this case, x plus 4. I'm going to multiply that on both sides. So if I'm multiplying and dividing by x plus 4 on the right side, those will cancel out. And then on my left side, x plus 4 times 0 is just going to be 0. So I end up with just my numerator set equal to 0. So I'm okay if you skip that first step and just kind of start here. But from here, we're going to add 9 to both sides. So 9 is equal to negative 3x. Then I will divide both sides by negative 3 and get x is equal to negative 3. So we'll have the point negative 3, 0 as our x-intercept. And then again, y-intercept is exactly the same. We're going to plug in 0 for x. So we'll have y is equal to negative 3 times 0 minus 9 over 0 plus 4. And what we end up with is just our numbers at the end, our constants. We have negative 9 over 4. And you can leave it like this. You can also write this as negative 2.25 if you want. So remember, it's an intercept. Write it as a point. We have the point 0, negative 2.25. Oh, I got an email. So these are all of the features for problem number 5. Let's practice again with problem number 7. So problem number 7, if we scroll, is f of x is equal to 2x minus 8 over x minus 2. So let's start with our vertical asymptote. Well, for our vertical asymptote, we set our denominator equal to 0 and solve. So you have x minus 2 is equal to 0. I'm going to add 2 to both sides, and I get a vertical asymptote of x is equal to 2. Perfect. And if we want to do our denominator, or our domain from here, for our domain, we'll have a break when we have a vertical asymptote. That's going to be from negative infinity to 2, and from 2 to negative infinity with that break because of our vertical asymptote. For our horizontal asymptote, we are going to take a look at the degree of our numerator and the degree of our denominator. The degree of our numerator is, I meant to change colors, degree of our numerator is 1, and the degree of our denominator is 1. So since the degree of the numerator is the same as the degree of the denominator, I'm going to take a look out in front, and I see that we have a 2 over, it doesn't really say anything, so I'm going to say it's 2 over 1. And 2 over 1 is just 2. So we're going to say that our horizontal asymptote is y is equal to 2. And again, we can say that because the degree of the numerator is equal to the degree of the denominator. And now that we have our horizontal asymptote, we can write out our range, which will have a break when we have a horizontal asymptote. So that's going to be from negative infinity to 2, and from 2 to infinity, with a break because of that horizontal asymptote. So we have both of our asymptotes, we have our domain and range. Lastly, let's find our x and y intercepts. So our x-intercept, you can set the whole equation equal to 0, or you can just set the numerator equal to 0, and have 0 is equal to 2x minus 8, and solve from here. So I'm going to add 8 to both sides, and get 8 is equal to 2x. I'll divide both sides by 2, and get x is equal to 4. So our x-intercept is the point 4, 0. So our x-intercept, and our y-intercept, there we go. You plug 0 in for x and solve. So we'll have y is equal to 2 times 0 minus 8 over 0 minus 2, which ends up being just our constants. So negative 8 over negative 2, which becomes a positive 4. So in this case, our y-intercept is 0, 4. And there we have it, all of the features for 2 problems. I'm just trying to get all of 7 in there. There we go. So these are all of the features for 2 of our problems. Hopefully the more you're practicing, the quicker this is going. In our next video, we're going to take a look at the tables and the graphs of these 2 problems as well. I look forward to seeing you then.